What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we are going to look at data science interview question number 58 up until number 69. Now, guys, I should mention we will see how far we can make it in this specific video. The important thing for you to note is that we are starting with question number 58. So let's get to it. Data science interview question number 58. What is meant by deep learning? So, artificial neural networks are a subfield of machine learning that is inspired by the structure and function of the brain. Machine learning encompasses a wide range of techniques such as linear regression, SVMs, and neural networks, amongst others. Now, while deep learning is simply an extension of neural networks, we examine a modest number of hidden layers in a neural network, but a large number of hidden layers in deep learning algorithms to better comprehend the input-output relationship. Now, guys, in simple terms, right, within the field of machine learning, there's a subfield called, neural networks. Neural networks is a type of algorithm. Now, deep learning is that subset of machine learning that specializes and deals primarily or entirely with neural networks. Okay, neural networks have these things called hidden layers, and the reason why we call it deep learning is because of the depth of the neural networks that we work with in deep learning. Okay, so the neural networks that you work with in deep learning, they have depths of 100 to 1000 plus hidden layers. So that's that. Now, data science interview question number 59. What are recurrent neural networks, RNNs, and how do they work? So recurrent nets or recurrent neural networks are a sort of artificial neural network that is used to recognize patterns in a sequence of data such as time series, stock market data, and data from government organizations. To comprehend recurrent nets, you must first comprehend the fundamentals of feed-forward networks. Both RNN and feed-forward networks get their names from the way in which they channel information through a sequence of mathematical operations conducted at the network's nodes. One feeds data straight, never contacting the same node twice, while the other cycles it via a loop, and the latter is referred to be recurrent. Okay, so that is that. Now, recurrent networks, on the other hand, use not just the current input example they view as input, but also what they have seen earlier in time. The BTS XPE at the bottom of the graphic indicates the current input example, whereas context unit represents the prior output example. The choice made by a recurrent neural network at time t1 has an impact on the decision made one moment later at time t. So, just like how we do in life, recurrent networks have two sources of input, the present and the recent past, which combine to influence how they respond to new data. Okay? The error they produce will be returned to them via backpropagation and used to adjust their weights until the error can no longer be reduced. Remember that the goal of recurrent neural networks is to classify sequential input appropriately. Backpropagation of error and gradient descent is used to accomplish this. Backpropagation in feed-forward networks proceeds backwards from the final error via each hidden layer's outputs, weights, and inputs, assigning those weights responsibility for a portion of the error by computing their partial derivatives. So, as you can see, or the relationship between their rates of change. Our learning rule, gradient descent, then uses those derivatives to shift the weights up or down, whichever direction reduces error. Backpropagation through time, or BPTT, is used in recurrent networks as an extension of backpropagation. Time is simply stated in this case as a well-defined ordered series of calculations linking one time step to the next, which is all backpropagation requires to function. So that's there. Now, on to question number 60. What is the distinction between deep learning and machine learning? So I will go through this, although we've just covered something similar. So anyway, machine learning is a branch of computer science that allows computers to learn without having to be explicitly programmed. Machine learning can be classified into the three categories below: supervised machine learning, unsupervised machine learning, and reinforcement learning are the three major types of machine learning. Deep learning. Deep learning is an area of machine learning that deals with artificial neural networks, which are algorithms inspired by the structure and function of the brain. Number 61. What is reinforcement learning and how does it work? Learning what to do and how to connect situations to actions is what reinforcement learning is all about. The goal is to maximize the numerical reward signal in the end. The learner is not informed which action to do. Instead, he or she must figure out which action will provide the greatest reward. Reinforcement learning is based on the reward and penalty mechanism and is inspired by human learning. So that is what we have here. Now, in my personal point of view, guys, reinforcement learning is a kind of field of machine learning that is not fully understood, not fully explored in today's times. Okay, and in my personal opinion, if we were to ever maybe have the potential to create some sort of, machine that is sentient and maybe conscious to some extent, my best say would be that reinforcement learning algorithms will have the ability to do that. Of course, I suppose using current algorithms, it may not be possible, but if I could guess, I would say in the future, if reinforcement learning has some breakthroughs and more discussions and depth to it, consciousness pertaining to machines is entirely possible. It would become too easy, okay, with reinforcement learning. So, on to 62. Explain the concept of regularization and why it is beneficial. So, regularization is the addition of tuning parameters to a model in order to produce smoothness and avoid overfitting. Adding a constant multiple to an existing weight vector is the most common way to accomplish this. The L1 lasso or L2 lasso constant is frequently used, ridge. The loss function derived from the regularized training set should then be minimized by the model predictions. And as you guys can see, there is a small graphic here which basically depicts the concept and procedure of regularization. That is fine. Now, on to question number 63. What is TF/IDF vectorization and how does it work? So, the term frequency inverse document frequency, abbreviated as TF/IDF, is a numerical statistic that measures how essential a word is to a document in a collection or corpus. In information retrieval and text mining, it is frequently employed as a weighting factor. The TF/IDF value rises in proportion to the number of times a word appears in the document, but is offset by the word's frequency in the corpus, which helps to compensate for the fact that some words appear more frequently than others in general. So as you guys can see, we also have an image here which shows us or tells us how to calculate the TF/IDF. Okay guys, so TF/IDF has to do with natural language processing, and I actually have an NLP tutorial planned for the series, for the YouTube channel actually, and I hope to have that out soon. Anyway, on to question 64. What are crucial data analysis skills to have in Python? The following are some of the most critical abilities to have while working with Python to perform data analysis. Number 1, thorough knowledge of the built-in data types, including lists, dictionaries, tuples, and sets. Number 2, n-dimensional NumPy arrays mastery. Number 3, data frame mastery using pandas. Number 4, NumPy arrays can be used to conduct element-wise vector and matrix operations. Number 5, understanding how to utilize the Anaconda distribution and package management. Number 6, knowledge of scikit-learn. Number 7, ability to use list comprehensions instead of standard for loops to develop efficient code. Number 8, ability to construct concise, clean functions essential for each developer, preferably pure functions that do not modify objects. Knowing how to profile a Python's script performance and how to eliminate bottlenecks. So that is what we have there. On to question number 65. What is the difference between data in the long and wide formats? So the repeated responses of a subject will be in a single row in the broad format, with each response in its own column. Each row in the lengthy format represents a single point per subject. The fact that columns often indicate groups helps you recognize data in a wide format. And there is a small visualization here, or a graphic, guys, that allows us to kind of logically distinguish between wide format and long format. Logically speaking, it's as the name implies, right? So like wide and long. So that's that. Now 66. What is the difference between overfitting and underfitting? So these are easy concepts to explain, guys. One of the most common jobs in statistics and machine learning is to fit a model to a collection of training data so that it can make trustworthy predictions on untrained data. When a statistical model is overfitted, it describes random error or noise rather than the underlying relationship. When a model is overly complex, such as when there are too many parameters in relation to the number of observations, overfitting occurs. Overfit models have poor predicting performance because they overreact to tiny changes in the training data. So, on to question number 67. What is supervised machine learning? Another easy question. The machine learning task of inferring a function from labeled training data is known as supervised learning. A series of training examples make up the training data. Support vector machines, regression, naive Bayes, decision trees, k-nearest neighbor algorithm, and neural networks are some of the algorithms that can be used from or for supervised machine learning. If you build a fruit classifier, for example, the labels will be this is an orange, this is an apple, and this is a banana, and so on, based on presenting the classifier apples, oranges, and bananas. So that is a simple explanation of supervised machine learning, guys. To make it even simpler for you in a one-liner, supervised machine learning has to do with working with training data that is labeled. Okay, there are definite labels for that data. Having labels will help the supervised machine learning algorithm to actually learn. Okay, so data science interview question number 68. What is unsupervised machine learning? Now, unsupervised machine learning, it's the opposite of supervised. Okay, so if supervised learning, machine learning dealt with data that has labels, unsupervised machine learning in simple terms deals with data that is not labeled. We say that the data is unlabeled. Anyway, unsupervised machine learning is a sort of machine learning method that is used to make conclusions from data sets containing unlabeled input data. Clustering, anomaly detection, neural networks, and latent variable models are some of the algorithms that are used. Example, fruit clustering, for example, will be classified as fruits with soft skin and plenty of dimples, fruits with shining firm skin, and elongated yellow fruits. So that is there. As you can see in this image, we can basically observe a simple explanation and differentiation between supervised and unsupervised machine learning. Now, this is the last question and answer for this video, guys. Now, data science interview question number 69. What does the activation function do? That is a good question. Now, the activation function is used to introduce non-linearity into the neural network, making it easier for it to learn more complex functions. Without it, the neural networks would only be able to train a linear function, which is a linear combination of the data that it receives. An activation function in an artificial neuron is a function that produces an output based on the inputs that it receives. So as you guys can see, these are common activation functions that we come across when we are dealing with neural networks. Sigmoid is a popular one, ReLU is a popular one. So that's that, guys. With that, That's all I have for you for this video. I hope you found it useful. I hope you found it insightful. With that, thanks for watching, guys. Thanks for staying till the end of the video. Good luck with your work, and I will see you in the next YouTube video.